Okay, let's do question 1 from homework 9. This is about a multiple linear regression where we want to predict the volume of a tree based on two other variables. One of them is height and one of them is diameter. So similar to what we had in simple linear regression, our response, which is volume, would be equal to intercept b0 plus b1 times height plus b2 times diameter. And the output of a software has given us the t-table that we usually have, the analysis of the intercept and the slopes, and is asking us to write the regression model. So y hat, or what we expected of y here is shown, would be the intercept, which the estimate is negative 57.99, plus the slope for the height, which would be 0.34, plus the slope for the diameter, which is 4.71, and that would be the linear equation that we have. Now it says if we keep this diameter constant, so the diameter is constant, this is not going to change, how much additional volume should we expect from an average tree if the height is increased by 1? So this is the definition of the slope for height. In simple linear regression, we said the slope is the amount of increase when the predictor is increased by 1. And that amount is the average, or what we expect to increase. It's not a perfect number. In this case, we have to say that diameter has to stay a constant number. And then when we increase height, the value that we get, which is 0.34, is the amount that we expect the volume to increase. So that would be exactly 0.34. Now it says, are each of these significant, the predictors that we have? So that relates to the p-value. If we are using 5% significance level, all of these three, which is the intercept and 2 predictor, are less than 5%, so they are significant. Therefore, at 5%, yes, since p-value associated with each predictor are less than 5%. Now here it says, predict the volume of a tree that is 79 feet tall and has a diameter of 11.3. In that case, all we need to do is we need to come back here and we need to plug in for height a number, which is, we had 79, and we need to plug in a number for diameter, which is 11.3, and we need to do the math, and we get our cubic feet of the volume. Here is giving us the actual volume of a tree, which is 79 feet tall and 11.3 inches of diameter. And it says the volume is actually 24.2. So are we overestimating or are we underestimating? That depends on the value that we found here. If the value is bigger, which would be a negative error, residual, we are overestimating. If this value is less than 24.2, then the error would be positive and we'll be underestimating.